8 reverse pairs. Okay. Let me just check the answer to that. So that was part of question 3. Yes, 8. All right. Okay. Now. All right. Now, actually, there's a bit more to. Well, it's question 4. All right. So you're given 3 permutations. I won't write them out. So you're given permutations A, B, and C, right? And the question is, you're to find the number of reversals in each. Now we've just done that once. I don't want to do it again. So, but you're told this. Well, let's say you calculate it, and you get that the number of reversals for A is 3, right? And the number of reversals for permutation B is 5. Okay? And the number of reversals for permutation C is 2. Okay? I'm assuming you can do the homework if you have the textbook. So I'm just giving this to you. So now, as I say, I'm just wanting to give one example of each technique, each concept that we did in the theory sessions. All right. So now then you're asked to deduce whether the number of reversals of AB and BC and CA, is it even or odd? Is it even or odd? Now, can you remember from the theory, a permutation is even if the number of reversals, reverse pairs, is even, by definition, right? That's where the concept, the term even and odd came from. All right? Okay, so we know the number of reversals for each of A, B, and C, and now we're asked to say, when you do 2 of them, like B first then A, or C first then B, or A first then C, each of these, are they even or odd? Okay. How do you do that? Well, one of the theorems was, can you remember this? Minus 1 raised to power n of x. Well, I'll do y. Yx. That equals minus 1 raised to the power of ny plus nx. Okay, remember that theorem? We used it quite a bit in the later sessions of this lecture. All right, now we can use that. So let's see. So what will AB be? So y and x here will just be AB, right? Now we know n of A, it is 3, and we know n of B, it is 5. So 3 plus 5 is 8. That's even, right? So this right-hand side is plus 1. So minus 1 to an even power is positive. That's plus 1. Okay, so that means that this n of yx also has to be even, right? So the answer to this is AB is even. Let me just check. So it's question 4. Yeah, even, right? Okay, now try BC. BC. So n of BC. So n of B is 5. N of C is 2. So 5 plus 2 is 7. That's an odd number. So minus 1 to an odd power gives you minus 1. That's the right-hand side. So the left-hand side must also be minus 1. So that means n of BC here has to be an odd number. Okay, has to be, and therefore BC is odd. Yeah, it's an odd permutation. Right? Using this. Well, I won't do this one because, well, just quickly. CA. All right. So 3 and 2. 3 and 2. It's 5. So it's odd. So this must be odd, and therefore C of A must also be odd. Right. So even, odd, odd. Okay. All right. Now, can you remember in the theory to determine whether a permutation is even or odd, there's a much quicker way, this is a slow way, using the number of reverse pairs. But there was a theorem saying that for each reverse pair, there was a crossover, cross point, when you connected the lines in the permutation, 1 to 1, 2 to 2, 3 to 3, and you just counted the number of cross points. So let's do that now. Alright, so the question is, use the method of lines drawn from the top row of a permutation to the bottom row, as in theorem 42, to determine whether the permutations, blah blah, are even or odd. Okay, I'll just do one of them. So here's the permutation. 1, 2, 3, 4, 5, and 1, 3, 5, 2, 4. Okay. Remember, this is a quick way to determine whether a permutation is even or odd. You don't have to go through all this. This took minutes, right? This will take like a few seconds. All right. So connect 1 to 1, connect 2 to 2, connect 3 to 3, connect 4 to 4, and connect 5 to 5. So how many cross points? 1, 2, 3. So we have 3 cross points. There was a theorem saying the number of cross points equals the number of reverse pairs. Okay. So we have 3 cross points, therefore 3 reverse pairs. That number is odd, and therefore this permutation is odd. So it's the first part of 5. Just check the answer. Odd, correct. All right. Okay. Now, you're given, I'll just do one of them, there's 3 in the questions. Question 6, you're asked to rewrite a permutation in terms of cycles, as a product of disjoint cycles. So here's the permutation. So 1, 2, 3, 4, 5. 3, 4, 5, 2, 1. Right? Now, strictly speaking, when you're doing this, when you're splitting them in a sense into disjoint cycles, because they're disjoint, they commute. So the order that you put the disjoint cycles, strictly speaking, doesn't matter. But maybe, I think for psychological reasons, it's probably a good habit to get into, is to put the first permutation, when you're doing several, is to put it on the right. So, I mean, if you don't do that, you may get into the habit of putting it anywhere, and then when your cycles are not disjoint, in other words, you can find some integers, you can find at least one integer that's in 2 different cycles. So when that happens, they don't commute. So, okay. So, let's see. So, well, I'm not sure how many cycles it's going to have, but let's guess that it's 2. All right. So 1 goes to 3. So 1 goes to 3. So we're writing cycles now, right? And they'll be disjoint because of the way we create them. So 1 goes to 3. 3 goes to 5. 3 goes to 5. 5 goes to 1. So there's one cycle. 1 to 3. 3 to 5. 5 to 1. Okay. This should first cycle. All right. So 1, 3, 5 we've used already. So from left to right. What have we not used? Like I said, 2 to 4. So 2 goes to 4, 4 goes to 2, and that's it. Right? That's it. So you have now 2 disjoint cycles. 1 goes to 3, 3 goes to 5, 5 goes to 1, 2 goes to 4, 4 goes to 2. This is actually a transposition because it's of length 2. It's just thrown in. Okay, question 6, just check the answer. 1, 3, 5 and 2, 4. Oh, that's interesting. Now, Barnard in the textbook, he has these 2 reversed. Now, strictly speaking, that's true, right? Because they're disjoint cycles, and therefore they commute. So we're both right, but like I say, for psychological reasons, probably better to stay in the habit that your first one you put on the right-hand side. Right. Okay, now we're going the other way. This next question, you're given a product of cycles, and you're asked to go the other way, to transform or rewrite this in the bracket form, right? So you go from this format to this format. So we're asked to do that, and I will